The following graph shows the approximate value of the United States Consumer Price Index (CPI) from December 2006 through July 2007. The approximating curve shown on the figures is given by the function I of t equals negative 0.04t cubed plus 0.4t squared plus 0.1t plus 202. This model is good for t between 0 and 7 inclusive only, where t is the time in months since the start of December 2006. Use the model to estimate the monthly inflation rate in February 2007, t equal to. Recall that the inflation rate is computed using the ratio I prime of t over I of t, where I is the consumer price index, the function given. All we're doing in this part A is to evaluate I primed when t equal 2 and I when t equal 2 and set up the ratio. That will give us the inflation rate. I of 2 is simply negative 0.04 times 2 cubed plus 0.4 times 2 squared plus 0.1 times 2 plus 202. Before we use a calculator to evaluate this, we need to find I prime of 2 as well. But in order to find I prime of 2, we first need to find I prime of t. Always find the derivative first before we plug in the numbers. The derivative of the first term, negative 0.04t cubed, is negative 0.12t squared using the power rule. The derivative of 0.4t squared is 0.8t. The derivative of 0.1t is 0.1, and the derivative of 202 is 0. And so I prime of 2 is negative 0.12 times 2 squared plus 0.8 times 2 plus 0.1. We then plug these two expressions into a calculator to find out what each of these values will be. For I of t, we'll get 203.48. And for I primed of 2, we'll get 1.22. The ratio of these two quantities will give us the inflation rate. And so the inflation rate, specifically when t equal 2, is 1.22 divided by 203.48, and this is approximately 0.00599568, which will round it to 0.006 or 0.6%. Part B. Was inflation slowing or speeding up in February 2007? The inflation will be slowing if the consumer price index is decelerating, and it is speeding up if the consumer price index is accelerating. But to answer a question about decelerating and accelerating, we would need to find the second derivative. We have the first derivative already. The second derivative, I double prime of t, is the derivative of negative 0.12t squared is negative 0.24t. The derivative of 0.8t is 0.8, and the derivative of 0.1 is 0. Then we would plug in 2 I double prime. This is negative 0.24 times 2 plus 0.8, or negative 0.48 plus 0.8, or this will give us 0.32. This number is positive that means that the inflation is speeding up because the consumer price index is accelerating. If the inflation is speeding up when the consumer price index is positive, and it is slowing when the consumer price index is decelerating. One is when the second derivative is positive, and one is when the second derivative is negative. And so to answer this question, we would need to find out where the consumer price index is 0 for the second derivative. And so for part C, we take the second derivative and we set it equal to 0. This means negative 0.24t plus 0.8 equals 0. And again, the reason why we take the second derivative and set it equal to 0 because we are answering question regarding speeding up or slowing down, accelerating or decelerating. Solving for t, we get negative 0.24t equals negative 0.8. T equals negative 0.8 divided by negative 0.24. And so t is approximately 3.33. This is in months. This is the number that will give us the second derivative equal to 0. And that is when t equals 3.33. In order to determine when the inflation is speeding up or slowing down, we still need to know the sign of the second derivative. And so if we pick any number in the first interval, such as t equals 1, and plug it into the second derivative, we'll see that negative 0.24 times 1 plus 0.8 will give us a positive number. And then if we plug a number after 3.33, such as when t equals 5, any number in this interval, we see that negative 0.24 times 5 is more than 0.8 but negative, and so the second derivative will be negative after t equals 3.33. What this means is that the inflation is speeding up to 3.33, and then it is slowing down after 3.33. T, the year's in 2006, and so when t equals 3, the corresponding year is 2009. We can also answer the last part by observing the graph. Observing that the consumer price index is increasing all the way, but it is increasing at a faster rate, and then it is increasing at a slower and a slower rate until it sort of taper off. What this means is that the direction at which the rate of the inflation rate is changing is somewhere in between accelerating and decelerating, and that is somewhere after t equals 3.